So friends, today we'll start with ray optics. What do you mean by the term ray? First we need to understand what is the actual meaning of a ray. Whenever there is a homogeneous medium means the medium will always remain the same. Either it will remain air, either it will remain water, either it will remain glass. The particle of the light will always travel in a same medium, only that case we are taking. Whenever the light is traveling in a homogeneous medium and also it travels in a straight line path, then that particular case is called as ray. So a ray is called as when the path of light traveling in a straight line in a homogeneous medium is called as ray. A bunch or a bundle of rays is called as a beam of light. So many rays or bunch or bundle of rays in that medium is called as beam of light. Understood? There are various ways, there are various types of beams. Various types of beams. One is convergent beam. Another one is divergent beam. And the third one will remain as parallel beam. So what is the basic difference between convergent, divergent and parallel? That we will study here. First of all, we will look about the convergent beam. What do you mean by a term called convergent beam? Whenever all the rays after crossing a particular medium, their area starts to decrease. So when there is a decrease in area, it is called as convergent beam. And when there is an increase in area, it is called as divergent beam. So decrease in area becomes convergent, decrease in area becomes divergent, and no effect on area becomes parallel. Now we have to study about two different type of optics. First we should know what is the basic difference between two different types of study of light, that is optics. One we say as geometric optics and the other one we say as wave optics. When you talk about the wavelength of a light, it is automatically considered under wave optics. And when you talk about the nature regardless of the wavelength of light, it is called as geometrical optics. But this is not the basic difference. The basic difference is when you have a material or objects that are not comparable to the wavelength of the light, then that is called as geometric optics. For example, your lens, your mirrors, your other objects, these you never compare according to the wavelength of the light. With that reference, we say it is called as geometric optics. And when you talk about slits, interference, superposition of a bunch of beams, that is beam of light, diffraction, such processes are having slits, and these slit width is actually comparable to the wavelength of light. Wavelength of light. That is called as wave optics. Now, we will first study about geometrical optics only, that we will study about lens, mirrors and other curvatures of the spherical surfaces. What we need to study therefore is geometrical optics is based on two phenomena. One is reflection and the other one is refraction. Now the name can easily be understood by the nature of the term. When the medium is same, whether it is the light that is incidenting or after striking the surface the light goes in the same medium, the striking light and the bouncing light both goes in the same medium, then it is called as reflection. And when the striking light and the bouncing light both goes in different mediums, that is medium is changed, then that process is called as refraction. For example, let's suppose this is a surface on which the light will strike. This is your striking light, which you always term as the incident ray. This incident ray is coming from some medium 1. Let it be air, water or anything else. And after striking the surface, this incident ray bounces in the opposite direction but remains in the same medium. Then that process will be termed as reflection. While in the other case, if you take incident ray in medium 1 and it bounces back, does not bounces back, but it goes into the other medium. So that means the medium is changed. That part is called as refraction. Now you can say here fraction. When you say a number as a fraction, if it is 2 by 2, it is not fraction, it is a proper number. If it is 2 by 3, if it is 4 by 5, if it is 7 by 11, then it is a fraction. Means when the numerator and the denominator will remain different, it is termed as fraction. And when the numerator and denominator will remain same, it is a pure same number, a whole number. That means when the numerator means the striking medium and the denominator means in which the light again goes back. So when the striking medium and the after striking medium both remain same, then it is reflection, because there will be no fraction included in that part. And when both are different, it will always be a fraction, because it cannot be a whole number, a pure simple proper number. Then it will be a refraction. So from now we will here study the case of reflection. Now we will study about the process of the phenomenon of reflection. Reflection means the medium will remain same after striking and before striking of the light ray. Let us suppose this is the striking surface. So every striking surface will have a perpendicular to it. That is termed as normal. Now, this is one surface and this is an incident ray, termed it as I1. We will talk about some coordinate geometry part. When we say coordinate geometry, our mind should understand that we are talking about x and y axis. If we are traveling along x-axis, it is I cap. Unit vector lies in the direction of x-axis I cap, and that in the direction of y-axis lies as j cap. When we are traveling in this direction, it is termed as minus I, and when we are traveling in this direction, it is termed as minus j. So here, there are two components of ray I1. What are the two components? One will be parallel to the striking surface, and one will be perpendicular to the striking surface. The one that is parallel to the striking surface never changes its direction, and the one that is perpendicular to its striking surface reverses its direction. That means if we are taking I1 as, since it is traveling in this direction, it is told as minus I cap, minus x I cap, and the other component that is perpendicular to it will also be in this direction, so that will be minus y j cap according to the coordinate geometry rules. Now, if this is the vector of I cap, I1 incident ray, that means when we talk about the I2 ray, that is, it will be going somewhere like this. This will be I2. I2, the parallel component, it is the parallel component, the x1, it is parallel to the striking surface, it never changes its direction. While the component which is perpendicular reverses its direction. That means it will continue to go in minus x, but this will change because it is perpendicular. So that means it is plus y j cap. So it will continue to move in this direction, that is negative x, and it will be positive. This is negative x and this is positive, and this direction will be plus I cap if you go in this direction. Now, if we again have some striking surface here, and this is the normal to this striking, the other striking surface. So the normal is in this direction, normal is parallel to x-axis, that means this direction is positive I cap. So it will reflect in this direction, that is I3. Now see the geometry. I2 when falling was having negative x component and positive y component, right? But now since the striking surface is on y-axis, so the parallel component remains same and the perpendicular component changes its direction, but parallel or perpendicular is decided by the striking surface. So now the parallel component will be the one that is on y-axis, and I2 parallel y-axis will be plus y, so I3 will remain plus y only, while the perpendicular becomes x-axis. So the x component becomes perpendicular, and perpendicular reverses its direction, that means it becomes x I cap. Now you understand? So that means always the parallel component of incident ray, which is parallel to striking surface, never, or you can say remains in same direction, while the perpendicular component to the striking surface reverses its direction, which I hope you can better understand by all these three geometrical rays. Understood? So this is the basic phenomenon of reflection. Now friends, we will talk about the principle of reversibility of light. What do you mean by principle of reversibility? Suppose this is an incident ray, this is the normal, and this is the reflected ray. So let us suppose this is AO and this is B. If AO is the incident ray, then BO is the reflected ray. So the principle of reversibility says if the path of light is reversed, it will again retrace its path. That means in the case 1, AO is incident ray and OB is reflected ray. So according to the principle of reversibility, if path of light is reversed, reverse means if now the BO becomes incident ray. If BO light becomes incident ray, that means it comes in this direction. The source from here is placed now here, and this is the source of light. So it will again retrace its path. That means OA will be the reflected ray. This principle is called as principle of reversibility of light. Now, with the principle of reversibility, we should learn laws of reflection, because in the next coming section it will be very beneficial. It says when you talk about the incident ray, when you talk about the reflected ray, and when you talk about the normal, the angle of incidence that is made between the normal and the incident ray, and the angle of reflection that is made between the normal and the reflected ray. So angle of incidence and angle of reflection is equal, and the incident ray, normal and the reflected ray all lies in the same plane. What do you mean by the term called same plane? Same plane means, let us suppose this is the striking surface. This will be the normal. So in the case, striking surface and the normal constitutes a plane. This is y-axis and this is x-axis, correct? So when you talk about these two parts, this is x-axis, this is y-axis, the incident ray is in xy plane and the reflected ray will also be in the same xy plane. That means the reflected ray, the incident ray and the normal all lies, because their point of intersection is same. Since their point of intersection is same, we can say all lies in the same plane. And angle of incidence and angle of reflection is same. Now, where can we use this concept? Actually, we have to learn about deviation of light ray by a mirror. Generally, it is a plane mirror. So, how can we talk about deviation that is produced by a plane mirror? Let us suppose this is a plane mirror. This is your striking incident ray. So the path should remain like this, right? This is the original path. This is the normal. This is the incident ray path. And this is the reflected ray path. Now, the angle of incidence was the angle made between the incident ray and the normal. Let us suppose it is at theta. So, by the laws of reflection, we can say that incident ray and normal is having an incident angle. So, the same angle will be made between the normal and the reflected ray, that is, will be equal to the angle of reflection. Now, this is your final ray, the path of final ray, and this is the path of your incident ray. Original path and the final path. Both are actually deviated by some angle called as del. So by the geometry, we can say that theta plus del constitutes a straight line. So that becomes 180 degree. So 2 theta plus del becomes 180 degree, and hence del becomes 180 degree minus 2 theta. So whenever the incident ray strikes a particular surface at an angle theta with a normal, then there is always a deviation from the reflected ray with the original path of incident ray by an angle of 180 minus 2 theta. Again, we can see this concept as this is the basic concept, that is angle of deviation, that is we are talking about this del produced by a single surface. This single surface, this is the angle of deviation, this is produced by that single surface. It depends on the angle of incidence, that is greater the angle of incidence, smaller will be the deviation, and could be vice versa. That is, if you increase this incident angle, the deviation will be small. If you decrease this incident angle, the deviation will be large. And that is too obvious. If we increase this angle, the original path ray will not be here, it will decrease. So the deviation will also decrease, right? And if you decrease this incident angle, so the original path ray shifts like this, so the deviation becomes greater. So both are vice versa, correct? I hope you understand this part. This is the basic phenomenon that we understand in the case of reflection. Now we are talking about two cases of the deviation that can be produced by the mirror or the incident ray. The first case is only the mirror remains in the same position. There is no change in position of the mirror. The first case gives us the implication that only I1, that was incident ray, is now shifted by an angle theta in anti-clockwise direction to another position called as I2. So since the mirror is in the same position, the reflected ray will be deviated by an same angle theta in the same plane of incidence, but in the opposite sense, that when it is rotated anti-clockwise, it will deviate by clockwise direction, and if it is deviated into clockwise direction, it will deviate through anti-clockwise direction. So the sense of rotation is different. Otherwise, the angle of deviation in both the cases, that is incident ray and the reflected ray, when the mirror is in the same position and it is not being deviated or shifted, it remains the same. Understood? But in the case when earlier the mirror was n1 and the normal was n1, the incident ray was making an angle phi with the first normal, that was position of n1. So the shift was 180 minus 2 phi, that we have already learned earlier. And when the mirror is shifted by an angle called theta, the normal also shifts from the earlier normal by an angle theta. So the new angle of incidence will become theta plus phi. So now the new angle of deviation will arise as 180 minus twice of theta plus phi. So the total angle of deviation between the two reflected rays, that is R1 and R2, can be found out by the help of del 1 minus delta 2, that we are assuming as x. So del 1 minus delta 2 is x. So delta 1 is 180 minus 2 phi and delta 2 is 180 minus 2 phi plus theta. So when you subtract both of this, you get 2 theta. That means the angle by which the mirror is actually rotated, the reflected ray is rotated by double that angle when line of angle of incidence remains the same.